Hello everyone, how are you all during this vacation? I think all of you are geared up to complete your school normal homework as well as started practicing sums from various books whose link I have already shared with you. Those Olympiad books mainly you need to practice from Mathematical Circle. I am taking the name of that with louder voice, Excursion in Mathematics, Challenges and Thrills of Pre-College Mathematics. Remember, these three are main books for you. In addition to that, some worksheets I have shared or I am going to share. The link will be given in the description box. You can download from there. You can practice from there. And that homework will be in accordance with the class I am taking here, with the session I am conducting with you. Hello everyone, MKS here. This session I am going to discuss on GCD. Have you heard of it? What is GCD? That is called Greatest Common Divisor. Probably up to class 10, you have done it in the form of HCF. Some of you are still in class 9 or in class 8 because you are aiming for those examinations in class 8 and 9 level also. So I'll be doing this session for all of you. But this is true that I'll not be doing school level problems here. If somebody has asked you to find GCD between 12 and 8, you are very prompt in answering GCD or HCF between 12 and 8 is equal to 4. Somebody has asked you, can you express the GCD between 18 and 24 as the linear combination of 18 and 24? This time you will get trouble. Linear combination I have probably already discussed with you. Today's class, let me start from there. Linear combination between two numbers. So let me explain what is linear combination between two numbers x and y. You can take any pair. I am taking x and y. A linear combination, or in brief, LC of these two numbers x and y can be expressed as z equal to ax plus by, where a and b also integers. A, b are also integers. Okay. So for example, if we want to write 2 as linear combination of 16 and 18, so the answer will be 2 equal to, your answer will be 2 equal to 1 into 18 plus minus 1 into 16. See, 2 is expressed as linear combination of 18 and 16 with the values of a as 1 and b as minus 1. Okay. What I told you that LCM between 18 and 24, we denote, sorry, not LCM, HCF. HCF between 18 and 24. What is the answer? This is equal to 6. You can easily express like previous one that 6 is equal to 1 into 24 minus 1 into 18. Here the same manner, 1 into 18 with a equal to 1, b equal to minus 1. Now I am taking two numbers, say 15 and 24. 15 and 24, their GCD is equal to 3. And just let me show you how 3 can be expressed as linear combination of 15 and 24. Then I will explain the significance of that equation. This 3 you can write 2 into 24 minus 3 into 15, isn't it? But initially with these small numbers by observation we are doing. Somebody has asked you, write the HCF between 45 and say 1005 in this form. Here really I have done it. What is GCD of 15 and 24? It is 3. And 3 I have expressed 2 into 24 minus 3 into 15. So what is the value of A over there? That A is equal to 2 and B equal to minus 3. But we are not doing class 6 and 8 or 9 normal school level syllabus. You have to understand that we are going to make the topic HCF or GCD what you did in your 6 to 9 or 10 classes. We have to make it symbolic. In general, we want to decide something. HCF between 15 and 24 you can find, you know the method. 78 and 36 you can find, you know the method. But there, that HCF, how can I express as the linear combination of two given numbers? Today mainly we are going to discuss about it, and then related problems I will be discussing here. Before that, let me revise the concept of GCD or HCF. Let there be two integers. I am just discussing concept of GCD. In brief, what you did in lower classes, that GCD between two numbers B equal to D. GCD, this is the symbol. Okay. Let AB equal to D. What does it mean? This implies that D divides A and D divides B. But problem, again there is problem. For example, I am taking the case of 36 and 54. What is the GCD between 36 and 54? This is 9 obviously. 9 no, 18. Because 18 will divide 36 and 54. So, 18 is the greatest integer which is dividing both, and 18 is a positive number. So, if we say that GCD between A and B equal to D, then the first condition is D must be a positive quantity. D must be greater than 0. That also I am adding here. D must be greater than 0. D can never be equal to 0. Can it be 0? No. Because if D is equal to 0, then 0 going to divide the other numbers. That is not possible in mathematics. And the third condition is, that will attribute after learning this thing. 36 and 54, there is safe 18. You agree or not? Now you see, 3 divides 18. 6 divides 18. 9 divides 18. All they are divisor of 36 and 54, but they are not greatest divisor. Greatest divisor is 18 only. So, if there be a number, say, that is if C divides A and C divides B, this will imply that C must divide D. Now the concept is clear. All these things you did here. Greatest common divisor you know. But greatest common divisor is a common divisor also. but that is the greatest among all the common divisors. This concept you should keep in your mind. And another very important concept, that GCD can never be negative. GCD always positive. Okay? Let us know about it with some examples. Like suppose you are considering GCD of 4 and minus 20. This must be equal to 4 and minus 20. This is equal to 4. If we take minus 4 and 20, then also it is 4. If we take minus 20 and minus 4, then also it is 4. So actually, when you are finding the GCD, remember minus A minus B, its GCD is nothing but GCD of mod A and mod B. This simple concept you have to keep in your mind. Okay? And another thing, GCD of numbers like 8 and 13 is 1. GCD of numbers 36 and 37 is 1. What these numbers are called? These are called co-prime numbers. Okay? These are called co-prime numbers. So, after learning the concept here, that GCD will be equal to 1 for co-prime numbers, there is no problem in remembering this, so that its future use is possible by you. Okay? These are also co-prime numbers. For any two co-prime numbers, their GCD will be equal to 1. I am not talking about prime numbers, talking about co-prime numbers. GCD of say 0 and 15. This is 0 or 15. This will be 15 only. 15 will divide 15 itself. 15 will divide 0. So GCD is 15 only. Am I clear? I hope all of you have understood. Now we are going to express GCD as linear combination of two given numbers. In fact, there is a theorem, but as we are not going to prove the theorem, I will not mention it as theorem. I will mention this one as a tool for number theory. Actually, this is Bayes-out theorem. Bayes-out theorem states that for two integers, their GCD can be expressed as linear combination of the given integers. I am talking about negative and positive, both the integers. Please keep this in your mind. Okay? So, what is the theorem here? That theorem is, I am just writing the form because proof we are not going to discuss here. Proof will irritate you, but realization of the proof is not a problem at all. Okay? So, what is that theorem? For two numbers A and B, if the GCD equal to D, then D equal to AX plus BY for some integers X and Y. Clear? This I have already showed you. Which example? Just look at this example. I was doing with 15 and 24. GCD of 15 and 24. 15 and 24 is equal to 3. And this 3 we have written as 3 into 15. No, 2 into 48, 2 into 24 minus 3 into 15. Isn't it? But for bigger number there is a problem. GCD of 8 and 13, if somebody has asked you to write that, 1. So this will imply that 1 is equal to, can you write this? How to write it? Just check. This we are writing 5 into 13 minus 8 into 8. With that X and Y as 5 and minus 8 respectively. This x and y you have taken here now. What is the value of x here? X is 5 and y is minus 8. Got it? But we want to generalize the process. And again, Euclid and Euclid only. Euclid's division algorithm will help you a lot. Okay? First I tell you how to get it with Euclid's algorithm. Then we will generalize the result. We will make some observations from there. Okay? What is Euclid's algorithm? Euclid's algorithm is step-by-step procedure of using Euclid's lemma. Isn't it? So suppose somebody asked you to find this only. How have you got this 5 and minus 8? Let us start with the easiest example. How do you start? With this, like 8 and 13, 1 you are saying, how 1 can be expressed this form? Did you memorize it? No. We will go by simple division process. Let me do it. This 13, I'll just remember this thing, A equal to BQ plus R. You are dividing A by B, then that we are writing in the form Q plus R by B. You agree with me? When I am dividing A by B, this result I am writing Q plus R by B. So for this one, you start writing this manner. 13 equal to 1 into 8 plus 5. Isn't it? My concern is about the divisor and the remainder. Okay? This is 8 and remainder is 5. So I am trying to express 8 in the form 5, 1 into 5 plus 3. Not over. Then GCD of 13 and 8 reduced to GCD of 8 and 5. Then now it is being reduced to GCD of 5 and 3. It is 1 into 3 plus 2. Not yet over. Now it is reduced to GCD of 3 and 2. 3 equal to 1 into 2 plus 1. And now 2 equal to 1 into 1. Sorry, 2 into 1. Clear? So no remainder. No remainder. Remainder equal to 0 here. So what have you told? Actually the method you have used, that when you go for long division, no, 1 by 1, you follow this process only. You are habituated. You have used in class 6-8 level only. So you should remember, go on dividing, get the remainder. With the remainder you divide, proceed that manner. So now I want to state this thing just by using the symbol A comma B. A comma B stands for what? The GCD between A and B. So here GCD between 13 and 8, 13, 8 reduced to 8, 5. This is reduced to GCD of 5, 3. This thing is reduced to GCD of 3 and 2. Am I correct? You all have understood? Now, the problem is to express this GCD as linear combination of 13 and 8. How to do it? That I am going to do. See, this class is on extended Euclid's algorithm, lemma, whatever you say, and or reverse Euclid lemma. With the Euclid lemma, you have got this thing. From the last step, I mean second last step, better to say, we are going back. What is the remainder in second last step? That you can see, that is equal to 1. So you start from there. This implies that the last step implies that 1 equal to 3 minus 1 into 2. From here you get 2. What is 2? 2 equal to 5 minus 3. You substitute. 5 minus 3. This is nothing but 2 into 3 minus 5. This 3 here is 8 minus 5. So you write 2 into 8 minus 5 minus 5. So this is going to be 2 into 8 minus 3 into 5. But 5 is what? There. This implies 5 equal to 13 minus 8. You just substitute 3 into 13 minus 8. Clear? So you got this. So 1 going to be equal to 3 into 5 into 8, 3 into 13. So have I got a wrong answer over there? Because initially I have checked that GCD can be expressed this form. 1 is 5 into 13. 1 can also be written as 5 into 13 minus 8 into 8. So what is this? Which part is wrong? 5 into 8, 40 minus 39 is 1. And 65 minus 64 is also 1. What is your opinion? Which one is correct? My answer is both are correct. I have never told you that representation is unique. I mean GCD of two integers a and b, this you can write as ax plus by, but I have never mentioned that x and y are unique integers. I told that for some integers x and y, it can have many solutions. Two solutions I have got. So two things are established with this example, that GCD really can be expressed as linear combination of given numbers. And what is the second thing? That representation may not be unique. Unique means you can express two or more ways. I have just showed you how to express in two ways. I thought that I'll get 15 into 5 into 13 minus 8 into 8. Then I reached different result. So it has the use here that to understand, one, the GCD can be expressed many different ways. I showed you just two methods. This is the standard one going back by Euclid's reverse lemma. Okay? Or extended Euclid's lemma. We can find GCD between two numbers easily if you follow this method, or you go by trial and error method. Okay? I am going to show you two more examples. How to get that GCD by reverse Euclid's lemma. Okay? Suppose I have taken two numbers 72 and 120. Okay? We have to find GCD of 72 and 120 and then express the linear combination of 72 and 180. The result. You write 120 is equal to 1 into 72 plus 48. Alright. Now you are dividing by 72. So you will put your mind on these two numbers. 72 is what? 1 into 48 plus 24. So initially it was GCD of 72, 120. Now it is reduced to GCD of 72 and 48. Now 48 is 2 into 24 plus 0. It is terminated here. You got GCD of these two quantities as 24. Okay. The answer is 24 here. Now we have to express 24 as LC, linear combination of 72 and 180 by Euclid's reverse algorithm. So you start from the second last step I told you earlier. 24 you write, 72 minus 1 into 48. Go step by step. In this step you got 24. But then there is a problem, I am getting 48. Here you will get 48. 48 is what? 48 is what? 120 minus 1 into 72. That is 2 into 72 minus 120. Am I clear? So it is done. Is it done? Check once, check once. So this is 144 minus 120. It is correct. So 24 you have expressed as 2 into 72 plus minus 1 into 120. This is a very important technique, very important topic in number theory. To express GCD as the linear combination of two given integers whose GCD you found. Next session I am going to show you how to apply all these concepts. Co-prime numbers have GCD 1 and GCD can be expressed as linear combination of two given numbers. This is very important. Whatever. What is x over there? X is 2 and y is minus 1. Clear? Let me take another example. Suppose you want to find GCD of the simplest one. Say 18 and 80. Their GCD you want to find and expressed is a linear combination of these two. So let us do it first because we are solving similar problem here. So you start this manner, that 80 equal to 4 into 18 plus 8. 18 equal to 2 into 8 plus 2. 8 equal to 2 into 4 plus 0. Terminated here only. Isn't it? So that GCD of 18 and 20 reduced to what? GCD of 18 and 8. It is reduced to what? GCD of 8 and 2. And that we got. So GCD answer is 2 over there. Clear? Now my problem is to express 2 as linear combination of these two. I don't have to find it by trial and error method. I'll be starting with the second last step. 2 will be 18 minus 2 into 8. Isn't it? 18 minus 2 into 8. That I did. That 8 you got in the previous step. 48. 80 minus 4 into 18. So write it here. Clear? So we got 2 equal to, this is what? 8, 9 into 18 minus 2 into 8. It is of the form z equal to ax plus by. AB are given number 18 and 80. So what is x over there? X is 9 and y is minus 2. Clear? Hope all of you have understood how to express the GCD between two numbers as the linear combination of two given numbers. Okay? You will find a very good application what we have just done here. 13 and 80, their GCD will be equal to 13p plus 80q. You find the values of p and q. Somebody can treat this one as an equation. Find a value of p and q. This is not unique, I told you. So that a 13 and 80, their GCD can be expressed as LC of 13 and 80. Similar question. So you can do it at ease. You start with 80. 80 equal to what? 6 into 13 plus 2. 13 equal to what? We are concerned about this one and this one, not the quotient. Dividing 80 by 13, you got 6. We are not little bit also not interested about 6. Only this and this. 13 will be 2 into 6 plus 1. Okay. It was LCM of 13 and 80. Now it is reduced to LCM of 13 and 6. Okay. Because when you are dividing 2 by 13, 6 is the quotient. No. It is reduced to HCF of 13 and 2. Now it is reduced to between 2 and 1. Because I told you, I will not think about the quotient, the divisor and the remainder. This 2 and 1 now. 2 will be equal to what? 1 into 2 plus 0. So it is reduced to 1, 2. Okay. Now you have to express when you are going to, they ask you to find P and Q. It is not unique. Many values are there. At least one you can get from here. No? How to? You start with the second last step from here. What you get here, that 1 equal to, always start with the quotient you get here. 13 minus 2 into 6. Then this will be 13 minus, what's the value of 2 here? From here 2 equal to 80 minus 6 into 13. So this will be 80 minus 6 into 13. This multiplied by 6. So finally it is going to be 37 into 13 minus 80 into 6. So ax plus by again. What is the value of a over there? A was 13 and b was 80. So what is x over there? X 37 and y is minus 6. Clear? So you have understood? If suddenly they have asked you to solve this equation, 13p plus 80q equal to 1. Solve, find the solution of this equation. You find the value of p and q. Can be asked in any way. Solution is here. One solution you got 37 and minus 6. Maybe other solutions are there. We'll think later. Right now we got a solution. Next one. You have to show that GCD of a and a plus 2 equal to 1 or 2. The basic difference between this class and the classroom in your school is that there you did this topic as arithmetic. But here we are doing algebraization of that part of numbers, integers. I am not saying that we are doing algebraic number theory. It is a very vast field of research. But right now you can think that we are bringing algebra in arithmetic. This is arithmetic problem. For any integer a, you take a equal to 5 and 7, their GCD is 1. You take 18 and 2, their GCD is 2. You take any value of a. This is what to say, more useful. We have done GCD or HCF of 2 numbers only. Here we are generalizing. If the numbers of this form, then GCD will be this. Okay? See how to do it. We'll do it with the help of this Euclid's algorithm only. Okay? And the concept of GCD. I'll show you other methods also. Let us do it by one method at least now. You are supposed to find GCD of a and a plus 2. I remember this, that GCD can never be negative. It is a positive integer. Okay. So you take, here it is given for every integer a. It doesn't mean that GCD will be integer with any sign. It is positive only. Even if you take a equal to minus 16. Minus 16 and minus 14. Their GCD is 2 only, not minus 2. That's what I'm telling. Okay. So let us start this manner. Let GCD of A and A plus 2 be equal to D. What does this imply? D divides A and D divides A plus 2. Am I correct? I remind you one thing we did in the second class work, that if an integer, just common division, that if an integer j divide A and j divide B, this implies j divide Ax plus By. Never forget this. Okay? Whatever you are studying in future, this is very useful concept. If a number j divide A, j divide B, it will divide their linear combination also. Already mentioned. You try to remember. You will remember it. I have reminded you now only. That if j divides A and j divides B, then j will divide Ax plus By. Isn't it? That A may be anything. A may be 5, B minus 2, A may be 1, B minus 1, anything. So what does this imply? This implies that D divides 1 into A plus 2 plus minus 1 into A. I have taken X as 1 and minus 1 as 1. Isn't it? So what have we got here? This implies D divides A plus 2 minus 2. D divides 2. So D equal to what? Plus minus 1 plus minus 2. I got 4 answers. Don't be happy, I am wrong. 4 answers not there. We forgot that GCD cannot be a negative quantity. So value of D equal to 1 or 2, not minus 1. Neither minus 1 nor minus 2. GCD can never be a negative quantity. One similar question is here. Find GCD of n plus 2 and 3n plus 8. How do you find it? Very interesting question. We got the simplest one here. You apply the same method here. That linear combination is divided by the same numbers. If j divide A, j divide B, j divide Ax plus By. Here, I will be starting the same manner to find GCD of n plus 2 and 3n plus 8. You start this manner. Let GCD of this thing be equal to D. This you can assume. GCD of n plus 2 and 3n plus 8 is D. So what does this imply? This implies that actually this is a question given in old Maths Olympiad paper. Okay? I don't remember the year properly. It was there. Okay? So gradually you are entering. Gradually I am going to show you how to solve all those Olympiad problems by using the concept we have already learned. Next one also hope I will be able to give you another one. Another masterpiece from Olympiad. Actually the easiest one. So what does this imply? D divides n plus 2 and D divides 3n plus 8. Should agree. So D divides A, D divides B. D will divide the linear combination also. Am I correct? So D will divide 3n plus 8 minus 3 into n plus 2. Why have I done this? Because I wanted to eliminate n. If n is there, it is very confusing. N is a number. We are going to prove a general case. If you take n equal to 5. 5 plus 2 is 7. 15 plus 8 is 23. There GCD you can find. You take n equal to 37 and then you find 39 and then 119. There HCD you can find. But let us see general result. If the numbers are of this form, their GCD going to be of this form. It's very important, no? You realize it? I hope you all have realized. So this manipulation is also very important. As a mathematics student, you should remember this for future. This implies D divides 3 and 3 and getting cancelled. 8 minus 6 is what? 2. This implies again D equal to plus minus 1 plus minus 2. Is it possible? Check. Is that possible? GCD cannot be negative quantity. Therefore, D equal to 1 or 2. Have I got correctly? Let us check. You take n equal to 5. This is going to be 7 for n equal to 5 and this is going to be 23. What is the GCD? They are co-prime numbers. 1. You take n equal to 4. For n equal to 4, you are going to find GCD of 6 and 20. What's the result? This is 2. So GCD can be 1 or 2. Simultaneously for one problem 1 and 2 both are not possible. It is either 1 or 2. Let us see another application here. This is a nice application of it. This kind of questions came in old Olympiad papers. So we should try to solve it. Let me explain the meaning of irreducible. What is the meaning of irreducible? Show that this and this are irreducible. Irreducible means if fraction 6 by 8 is there, we can write 3 by 4, cancelling 2 from numerator and denominator. If fraction 7 by 23 is there, I have to write that. You agree or not? We cannot cancel any factor. So we say that this fraction is irreducible. It means we cannot make into a smaller fraction. But this one, 6. This 6 by 8 is reducible. Am I clear? You all understand? Again, we are going to generalize the result. If numbers are of this form, they are irreducible. You cannot get a common factor over there. Just use the concept of GCD here. When we cannot cancel a common factor, if the number is of this form 51, 52. If the numbers are of this form 68, 79. What are these numbers? They are co-prime numbers. If you can prove that the numerator and denominator, they are co-prime numbers, then it is done. With your simple arithmetic concept, it is not possible. But easily you can solve it with the concept we have learned today. We will find their GCD. GCD of 9n plus 8 and 6n plus 5. And then we will decide if GCD equal to 1, there is no common factor. If GCD is not 1, there is a common factor. Then I have asked a wrong question. Let us see what is the GCD between these two numbers. Let us start with this one. Let D equal to GCD between 9n plus 8 and 6n plus 5. This implies D divides 9n plus 8 and D divides 6n plus 5. Am I correct? This implies that go by linear combination method. D divides, and I told you in the previous sum, my aim is to remove n from there. Decision making will be easier. Going to remove n from our calculation. Multiply this by 2 and this by 3. And that is possible because D divides A and B means D divides their linear combination. So D divides 2 into 9n plus 8 minus 3 into 6n plus 5. Am I clear? So this implies D divides, see 18 and 18 getting cancelled, 16 minus 15. So D divides 1 and it is the greatest positive integer. So what is the solution over there? So D is equal to 1 only. So GCD of this implies that GCD of 9n plus 8 and 6n plus 5 equal to 1. It will make the fraction irreducible. We cannot cancel any common factor between these two numbers. Similar is the case for next one. You can practice with me in this session. You have the scope. You can finish it before I do it here because you got the idea. Irreducible means you have to prove that GCD of numerator and denominator is equal to 1. I am going to do that. 15n plus 4 and 12n plus 3, their GCD be D. Let GCD of 15n plus 4 and 12n plus 3 be D. This implies what? This implies that D divides 15n plus 4 and D divides 12n plus 3. This implies that it is, my aim is to eliminate n. How can I do it? Multiply this by 4, this by 5, 60 and it get cancelled. So 4 into 15n plus 4 minus 5 into 12n plus 3. These two are getting cancelled. 16 minus 15 is 1. So this implies D divides 1. Therefore, D is equal to 1. Understand? So, in the second fraction also, you cannot get any common factor, never, ever. By putting any value of n, this kind of fraction irreducible. It's a very important problem in integers, in number theory. Okay? So, try to practice the material I have shared with you. You will find in the description link. Some of you got it via WhatsApp. I don't have all of your WhatsApp number. I could not share it. Now finding all those algebraic numbers, their GCD. This I'll say theorem or important result which I am going to prove. You can treat this one also as a problem. And the result you can use even including the previous sums, which will help you to solve the sum in fewer number of steps. What is that? Why I am so enlightened to explain that? It is just GCD of A and B can be written as GCD of A and B plus AX. Very common observation which can be used for previous sums. Today I will be giving you the proof. You try to get it, previous sums or the problem sums I have shared with you with the help of this concept. You start this manner. Let A be their GCD equal to D and A comma A plus BX is equal to E. Okay. You are going to prove that D equal to E. Then it is done. Because AB is H shape D. A and B plus X, H shape is E. If you can prove that the value of D and value of E same, then it is done. Now what does this imply? This implies that D divides A and D divides B. This implies that D divides A and D divides the linear combination B and A. One of the linear combination, X is integer, you can take 1 into B plus A into X. Isn't it? So D divides A and D divide, wait a minute, this you write, D divides A and D divides B plus X. But A and B plus X has GCD E, and this is the largest number. So by the concept I told you today, this should imply that D must divide E. Why? E is the GCD between A and B plus X. So a number which divide both of them, both A and B plus AX, must divide their GCD. So you remember this, that D divides A as 1. Now let us start from here. From where? That E divides A, this implies this thing implies what? E divides A and E divides B plus X, isn't it? This implies E divides A and E divides B, E divides AX, because E divides B and E divides AX, that's why E divides B plus AX. But there is no difference between these two, E divides A and E divides AX. I am combining these two. We are combining these two parts. This gives E divides A and E divides B. So this implies that what? This is the greatest common divisor. Now you are claiming that E divides A and B. So E is a common divisor. This implies E divides D. Mathematics is fun, finally. You have got D is dividing E and E is dividing D. How is it possible if they are not equal numbers? So therefore, D must be equal to E. And this step will ensure that, this calculation will ensure that GCD of AB and GCD of A, B plus AX is the same thing. So if you say that, can't I write this one, GCD of A and GCD of A plus 2? How can I write it first? You can write, this is GCD of A and GCD of A plus 2 minus A. This is GCD of A and 2. But A we don't know. Sometimes this method works nicely. Sometimes you have to put more effort to do. But this derivation, what I did today and the sums, you should keep in your mind. Next class, I am coming with more problems on it from Olympiads, and additionally I will explain what is Diophantine equation with the help of what? With the help of Euclid's lemma or Euclid's division algorithm. Thank you for staying with me till the end. See you again.